Hello students, welcome to my channel. I am Sumit and this is my fifth lecture on polar coordinate system. And in today's session, we'll derive the equation of conic using polar coordinates, and we'll also find the equations of its directrices. So still now we have studied about the fundamentals of polar coordinates. We have derived the equation of straight line, the circle in polar form. Okay, so I hope your fundamentals are clear, but still if you haven't watched my previous videos and if you have no idea about polar coordinates, you can check it out. Okay, so still I'll explain some of the basic fundamentals here also, so that you can continue with the discussion without any hesitation. Okay, so let's start with the discussion. Now for them who don't know about polar coordinates, basically there is a fixed point O which is called the pole. Okay, and a fixed line OX which is called the initial line. Okay, with respect to this fixed point O and OX initial line, with respect to this reference, we can locate the position of any point in this coordinate plane. So this point is P, R, theta. Okay, this is the coordinate of point P in polar coordinate. Here R is the distance of this point P from the pole. This distance is R, which is called the radius vector. Okay, and this angle means the radius vector angle made by the radius vector with the initial line is theta. Okay, this is called the vectorial angle. So this is the basic of our polar coordinate system. Now you all might be aware of the conics. Okay, conic section. Conic is basically the section of a cone by a plane which generates a conic section. It can be a parabola, it can be an ellipse, a hyperbola. Okay, and you have studied about this in rectangular Cartesian coordinate system. So we'll derive the equation of general conic using this polar system. Okay, so here we are given a fixed line which is called the directrix and a fixed point which is called the focus. With respect to the fixed line and focus, with respect to the directrix and focus, we can define any conic. Okay, so how can we define a conic? Let this be a general conic. Okay, this is not a parabola. This is a general conic. It can be an ellipse, a hyperbola, a parabola, anything else. It depends upon the value of eccentricity. So what is eccentricity? If there is a point P, say r, theta is the general point P on this conic. So this point moves along this conic. Now the distance of this point from the focus is divided by the distance of this point from the directrix. If we draw a perpendicular to the directrix, then this distance, say this is m. Okay, so we know E means eccentricity is equal to Sp by Em, and with this ratio we can define any conic. It depends upon the value of E. If E is equal to 1, then it is a parabola. If E is less than 1, obviously greater than 0, since it's a ratio of lengths. So ratio, so obviously E is greater than 0. But if E is less than 1, it's an ellipse. And if E is greater than 1, this is a hyperbola. Okay. Now we derive its general equation, means general equation of a conic. Okay. So say this is a general conic. This is a general conic, and the speciality of this conic is that we take its focus as a pole. Okay. So we derive the equation of a conic whose focus is taken as a pole. So the initial line passes through the focus. So this is Sx is the initial line, and S is the focus of this conic and the pole. Okay. So we have to find the equation of this conic. Now, basically we have to find the locus of point P. Since point P is an arbitrary point, it moves along this conic. So if we can find the locus of point P, we'll be able to derive the equation of the conic. Okay. Let me draw it better. This, okay. So this is the directrix. Say RT is the directrix. Now we draw a perpendicular from point P to the directrix. Okay. So this is a perpendicular from point P to the directrix. TN is a perpendicular from point P to the directrix, and we also draw a perpendicular to the initial line, say PN. Okay. Now the semi-lattice rectum, the lattice rectum of this conic is L dash, and the length of semi-lattice rectum is given as small l. Okay. So small l is the length of semi-lattice rectum. Now we draw one more perpendicular from L to the directrix. Say this is LP. Okay. So from here we can say that since the coordinate of point P is r comma theta, this length is r and this angle is theta. Okay. So we can say that cos theta is equal to base upon hypotenuse, base Sn divided by hypotenuse Sp. So Sn by Sp. From here we get Sn is equal to, okay, Sp is nothing but the length r. Okay, so this is equal to Sn by r. From here we get Sn is equal to r cos theta. Keep this in your hand, we'll use this. Now since P is a point on the conic, we can say that this distance Sp divided by this distance Pn is nothing but the eccentricity. So we can write Sp is equal to E into Pn, eccentricity E into Pn. Okay. So eccentricity Pn. Now Pn is this distance, which is nothing but this distance Rn. We can write Rn instead of Sp, instead of Pn. So here we write E into Rn. Okay. So this is equal to, now Rn is Rs plus Sn. So this is equal to Sr plus Sn. Okay. Now this implies that Sp means this distance, which is r, is equal to, okay, in place of Sr we can write Lq. In place of Sr is this distance, so we can write Lq instead. So r is equal to Lq plus Sn. Okay. From here we get r is equal to Lq plus Sn. Now Lq, if you observe carefully, L is a point on the conic. So we can say that this distance Sn divided by this distance Lq is equal to eccentricity of the conic. So Sl divided by Lq is equal to E. We can write here, which implies that Lq is equal to Sl by E, and Sl is the length of semi-lattice rectum. So this is equal to L by E. So here in place of Lq we can write L by E. So this implies R is equal to L by E plus, okay, there was an E here, eccentricity E. So this is E into L by E plus Sn, and we have already found that Sn is equal to r cos theta. We already derived this. The Sn is equal to r cos theta. So here we can write r cos theta. Okay. Now multiply E and you get r is equal to L plus er cos theta. Which implies if we take this side and take r common, then r into 1 minus e cos theta is equal to L, which implies L by r is equal to 1 minus e cos theta. Okay, so this is the required equation of conic. This is the equation of conic in polar form whose eccentricity is E. Now depending upon the value of E, we will find whether this is an ellipse or hyperbola, a parabola, etc. Okay. Now this is the equation of a conic when the initial line is taken, the positive direction Sx is taken in the right direction. There is one more equation of this conic. When we take the initial line Sx in the left direction. Okay, so we derive its equation also. First we note it down. Okay, so we'll now derive the equation of conic whose initial line focus is taken as pole and the initial line Sx is taken in left direction. Okay, so I'm drawing the figure first. So this is our directrix and this is the initial line. Here we take the positive direction in left. Okay, so this is x and this is the general conic whose focus is S. Focus is taken as pole. So Sx is the initial line, positive direction of initial line is Sx and S is the pole. Now L is A dash is the lattice rectangle. Okay, so there is a general point P r comma theta on this conic and we have to find the locus of point P. So we draw perpendiculars. This is L. From L to the directrix, say L is perpendicular. Then we draw a perpendicular Tn to the directrix and one more perpendicular Tn is dropped to the initial line. Okay, these are all perpendiculars. Now if we connect point P to the focus S, then this is the pole. So S is the pole and the focus also. So we can say this distance is r and this angle is theta. Why this angle? Because here we have taken the positive direction this side and the radius vector r is making this angle with the initial positive direction of initial line. So this is theta. Okay, so if this is theta, then we can say this angle is pi minus theta. Okay, so now we can say from this triangle PSN, cos of this angle means cos of pi minus theta is equal to base Sn divided by hypotenuse Sp, which implies this is minus cos theta is equal to Sn by Sp is nothing but the radius vector r. So this implies Sn is equal to minus r cos theta. Take this in your hand. Reduce this. Sn is equal to minus r cos theta. Okay. Now P is a point on the conic, so we can say that Sp is equal to EPN, which is equal to E into Pn is this distance, which is nothing but this distance, and this point is T, so we can write Tn instead. And Tn is St plus Sn, so this is equal to E into St plus Sn, which is equal to ST means this distance LQ. So LQ E into LQ plus SN. Now this implies SP means this distance R, radius vector R is equal to E into LQ. Similarly we get L is a point of the conic. So we can write that SL by LQ is equal to E, and from here we get LQ is equal to SL by E, and SL is this distance, which is the length of semi-lattice rectangle. So LQ is equal to L by E. Okay. So instead of LQ we'll write L by E plus, instead of SN we'll write minus R cos theta. So here we write minus R cos theta. Then if you simplify this, you will get the equation of the conic, and that is L by R is equal to 1 plus E cos theta. Okay. So this is the equation of the conic when the initial line is taken in left direction. We'll use both of these equations. We derived earlier that L by R is equal to 1 minus E cos theta. In this case we take the initial line in right direction, and in this case we take the initial line in left direction. Okay, we'll use both these equations. So you should remember these equations. These are very important. We'll use this while problem solving. Okay, so note it down. Now students will derive the equation of directrices. Now when you talk about any general conic, like it can be a parabola, hyperbola, a circle, anything, we just have to consider one focus and one directrix. But in case of ellipse, we deal with two foci and two directrices. So there are two pair of focus and directrices. Okay, so here we will derive the equation of both the directrices using polar form. Okay. But for that we will use only one focus and one directrix. Okay. So first we will derive the equation of nearest directrix, then we will derive the equation of farthest directrix. So I am drawing the diagram here. So this is one directrix and this is another directrix. Okay. This is our initial line, and here we take the positive direction in right. Okay. So this is a general point. I have drawn this like an ellipse because we have taken two directrices, but consider this as a general conic. Now we use this focus and this directrix to derive the equation. Say this directrix is G and this is given as G dash. We use only this pair of focus and directrix to derive the both the equations. Okay. Now S is the focus and it is taken as a pole. So S is focus and it is a pole. Sx is the initial line. Okay. This is the lattice rectum L dash, and the length of semi-lattice rectum is given as small a. Okay. So we take a general point P r comma theta on the directrix. Okay, so the equation of this conic is given as L by R is equal to 1 minus E cos theta. Obviously, this is the equation since we have taken the initial line, positive direction of initial line in right direction. So the equation is given as L by R is equal to 1 minus E cos theta. Now there is a general point P r comma theta. So this arbitrary point moves along this directrix, and we have to find the locus of point P to derive its equation. Now we connect this point to the focus. Since this is a pole, we can say this distance is r and this angle is theta. Okay, this is our initial line and this is radius vector, so this angle is vectored angle theta. Say this is point V dash and this is point, no, this is point V, this is point A. This is A dash and this is V dash. Okay, we'll come to this directrix later. First, we derive its equation. Okay. Now, from the diagram, we can say this angle is theta, so this angle is pi minus theta. This angle is pi minus theta. So we can say cos of angle P is V. Cos of angle P is V is equal to base divided by hypotenuse. So base is ASB divided by hypotenuse is AC, which implies cos pi minus theta is equal to ASB by SP means this distance, which is the radius vector R. It implies ASB is equal to R. Okay, cos pi minus theta means minus cos theta, so this is minus R cos theta. Okay. Now ASB is this distance. Okay. One more thing is we drop a perpendicular from L to the directrix. Say this is AD. Okay, this is also perpendicular to the directrix. Now we can write TL instead of SB because this distance and this distance are equal. So we have TL is equal to SB or SB is equal to TL. Okay, I don't know if this is visible. Let me check. Okay, this is visible. So SB is equal to TL. This distance is this distance, and we can say that L is a point on the conic. So this distance SL divided by this distance TL, SL divided by TL is equal to E eccentricity. From here we have TL is equal to E into SL by E. Okay, and SL is the length of semi-lateral spectrum. So we have TL is equal to small l by E. We use this latter also to derive its equation. Okay. Now in place of SB we can write TL, and in place of TL we can write L by R. So from here we get L by R is equal to minus R cos theta. Oh, sorry, this is actually TL is equal to L by E. So we have to write E. So L by E is equal to minus R cos theta, which implies that L by R is equal to minus E cos theta. And this is the required equation of this directrix, means the directrix G, the nearest directrix. Nearest directrix. Equation of nearest directrix. Okay. Nearest directrix means here we have considered the focus S as pole. So its nearest directrix is this one. So this is the equation of nearest directrix. Now we will calculate we derive the equation of farthest directrix also. So students, this equation is very easy to remember, as the equation of the conic is given as L by R is equal to 1 minus E cos theta. So we just have to remove 1 from here. We will write L by R is equal to E cos theta. This is the equation of nearest directrix. Now if the equation of the conic is given as L by R is equal to 1 plus E cos theta, then the equation of its directrix is given as L by R is equal to plus E cos theta. Okay, so this is very easy to remember. Now we shall derive the equation of farthest directrix. First, note it down. So now we will derive the equation of farthest directrix. Okay. So I am writing this. we'll use this here also. Equation of the point is given as L by R is equal to 1 minus E cos theta. Okay. Now we take an arbitrary point, say Q, rho comma, say you can say phi. Okay. Rho comma phi is an arbitrary point on this directrix. So this point moves along this directrix, and if we can find the locus of point Q, we will be able to derive its equation. So we connect the focus or the pole to the point Q. So this distance is rho units, and this angle is phi. Okay. Now from the diagram we can say cos of this angle means cos phi. Cos phi is equal to base upon hypotenuse. Base is SB dash divided by hypotenuse is SQ, which implies that SB dash is equal to SQ means this length, which is equal to the radius vector rho. So this is rho cos phi. This is the equation of directrices, but we do not know SB dash. So we first have to find the length SB dash. Okay, keep this in your hand. Now students, A and A dash are points on the conic. So we can say they must satisfy this equation. Yes. Now we have to know the coordinate of point A and A dash. So the coordinate of point A is, since this is the pole, SA is the radius vector. We can say SA is the radius vector, comma, and the vectorial angle is this entire angle. Since SX is the initial line and SA is the radius vector, so the radius vector makes an angle of pi with the initial line. So SA comma pi is the coordinate of point A. Similarly, the coordinate of point A dash is SA dash comma 0. Since the radius vector SA dash coincides with the initial line, so it makes an vectorial angle, not theta, a vectorial angle of 0 degree. Okay. So these are the coordinates of point A and A dash, and these points must satisfy this equation. So we'll put this here, and we get L by, in place of R we write SA is equal to 1 minus E cos, this is pi, so E cos pi is minus 1. From here we get SA is equal to L by 1 plus E. And similarly if you put A dash here, you will get SA dash is equal to L by 1 minus E. Okay. Now these are two important expressions we use this. SA is this length and SA dash is this length, but we have to find the length of SV dash. Okay. So now observe carefully. A is a point on the conic, and S is the focus, S is the pole. Okay. So we can say that this distance SA divided by this distance AV. This is the distance of point A from the directrix. So this distance SA divided by SB is equal to eccentricity E. We can write eccentricity E is equal to SA divided by AV. Okay. Also, A dash is a point on the conic. So here we have taken this pair of focus and directrix. So from the distance of point A to the A dash divided by A dash V is the eccentricity, so we can write this is equal to S A dash divided by A dash V. Okay. From here we get S A dash. S A dash. S A dash is equal to no, sorry. A dash V, we get A dash V. A dash V means this length. We get A dash V is equal to S A dash by E. And we have already derived that S A dash is equal to L by 1 minus E. So here we can write, I am writing this here. A dash V is equal to S A dash by E. S A dash is L by 1 minus E. So this is equal to L by E into 1 minus E. Okay? A dash V is equal to L by E into 1 minus E. Now students, what is A dash V dash? A dash V dash is this length, and you know this length for an ellipse, this length A dash V dash is equal to this length AB. So we can say that A dash V dash, I am writing A dash V dash is equal to AB. Okay, and AB, from here we can say AB is equal to AB is equal to SA by E, SA divided by E. Okay, is this visible to you? Okay, so AB is equal to SA by E. This is A dash V dash, this length. Now SA is, we have already derived, AC is equal to L by 1 plus E. So we put this here and we get A dash V dash is equal to L by E into 1 minus E. Okay, this is A dash V dash. So we got A dash V means this length and A dash V dash means this length. So we can write the length V dash is equal to A dash V plus A dash V dash. So write this here. Now students, I am writing this here. I will not get enough space rather. So actually we use this and this latter. So S V dash is equal to rho into cos phi. Okay. Now V dash, this length V dash is equal to, we can say this is equal to A dash V plus A dash V dash, A dash V plus A dash V dash. This is equal to A dash V is L by E into 1 minus E. So L by E into 1 minus E plus L by A dash V dash is L by E into 1 minus E. So I think this will be 1 plus. Okay. So from here we get 2L by E into 1 minus E square. This is our V dash. But we have to find S V dash. So now we can subtract S V from V dash and we will get our required S V dash. Okay. So SB is this length and this length is nothing but LB. We have already derived SB is equal to TL, which is equal to L by E. So we can write here, I am writing this here. We can write here that SV dash is equal to V dash minus V dash, this length, minus SV, which is equal to V dash minus SV is equal to TL. So this is PL. Okay. Now VB dash is equal to 2L by 1 minus E square minus PL is equal to L by E, and if you simplify this, you will get L by E into 1 plus E square divided by 1 minus E square. Okay. So this is our SV dash, and we can put this here, then we will get the required equation of the directrix. So the equation of the directrix is, in place of SV dash, we will write L by E into 1 plus E square divided by 1 minus E square is equal to rho cos phi. Okay. Now we just replace rho and phi by r comma theta. Like when in Cartesian coordinate system, when we derive the locus, we take a point h comma k, and then we replace this. Finally, after getting the relation between h and k, we replace this by x comma y for a better general form. Okay. So similarly, here we have taken rho comma phi, so we replace this by r comma theta. Then we get, this is L by E is equal to r cos theta. L by E into 1 plus E square by 1 minus E square is equal to r cos theta, and this is the equation of the farthest directrix. Equation of the farthest directrix. Equation of the farthest directrix. Okay. Farthest means this directrix is located far from the focus is. Okay. Now there is a homework for you. Already I have told you that there might be two equations of this conic. So if the equation of the conic is given as L by R is equal to 1 plus E cos theta, you have to find the equation of the farthest directrix. Okay, this is the homework for you. You will do it on your own, and you will get the answer in my PDF notes, which will be attached in the description box. Okay, so note it down. So students, now we will solve some problems. State the nature of the conic. The equation of the conic is given in polar form, and we have to state its nature. So to state whether this is a parabola or ellipse or hyperbola, first we have to find the eccentricity. Okay, so let's simplify this equation. 4 by r is equal to 3 minus 3 cos theta. So divide both sides by 3, and you get 4 by 3 divided by r. This is equal to 1 minus 1 into cos theta. Okay. So here this is L by r is equal to 1 minus E cos theta. So eccentricity E is equal to 1. Hence the ellipse, the equation represents a parabola with length of similar rectum 4 by 3 units. Hence it is a parabola with L is equal to 4 by 3 units. L is the length of similar rectum. This is 4 by 3 units. Okay. The next is a homework. You will do it on your own. Okay. So we'll move forward to the next question. Students, next problem. This is a very interesting problem and very important also. This question is asked in many of the universities providing BSc Honors and BSc General degree courses. So prove that the semilateral rectum of a conic is the harmonic mean between the segments of focal chord. Okay. Basically, there is a conic. So this is our conic. Its focus is L and Sx is the initial line. So the equation of the conic is that the equation of the conic be L by R is equal to 1 minus E cos theta. Okay, this is the equation of the conic. Now this is the latus rectum L S L dashed. Okay. And this is a chord. Lattice rectum is a focal chord which is also a double ordinate. But there is another focal chord, say P S P dashed. Okay. So the length of semi-lattice rectum is given as small l. Now we have to prove that this small l means the length of semi-lattice rectum is the harmonic mean between the segments of focal chord. This is a focal chord. So this is also a focal chord. We can prove this by the lattice rectum also. And this for the better understanding I am doing this. So this is SP and this is SP dash. These are the segments of focal chord. We have to prove that their harmonic mean, that is 2 by 1 by SP plus 1 by SP dash is equal to L, the semi-lattice rectum. Okay. So how can we prove this? See, P is a point on the conic. So this angle is alpha. This angle is alpha. Okay. Now the coordinate of point P is SP comma alpha. We can say the radius vector is SP and the vectorial angle is alpha. So the coordinate of point P is SP comma alpha. Now if this angle is alpha, this angle is alpha plus this entire angle is this obtuse angle is alpha plus pi. So the coordinate of P dash is SP dash comma pi plus alpha. Okay. Since they lie on the conic, they must satisfy the equation. So we'll put this here. We get L by SP is equal to 1 minus E cos alpha, and L by SP dash is equal to 1 minus E cos pi plus alpha, which is equal to 1 minus 1 plus E cos alpha. Okay. Now add these two equations. Say this is our equation 1, this is equation 2, and this is equation 3. Okay. Now add these equations 2 and 3, and you will get this plus this is equal to this plus this. So E cos alpha is cancelled out, and we get 1 by SP plus 1 by SP dash is equal to 2 by L, hence proved. Okay. Okay. Now students, this is a homework question for you. Find the respective polar equations of the right and left branches of the hyperbola 9x square minus 16y square is equal to 144. Okay, this is a homework. You'll find its solution in my PDF notes, and also I will discuss this in my next videos. So this is all for today's session. Thank you for watching. If you have any doubts regarding the discussion, let me know in the comment section. Also for the PDF notes of this session, check out the description box below, and keep studying and keep growing.